Right. Sometimes when we're dealing with problems with force of gravity or gravitational field strength, we'll try and play with the wording a little bit to trick you. So these ones you're going to have to be a little bit more careful with. So let's see what the problem's asking, and then we'll show you what to do from there. So we got a probe. It's going to determine the gravitational field strength above the surface of Venus. It's about 5.50 newtons per kilogram. So we're given Venus's mass. It's 4.87 times 10 to the 24 kilograms. And it also has a mean radius about 6.05 times 10 to the 6 meters. So we would like to determine the altitude of the probe. And by altitude, this is the measured from the surface of Venus. Now, this might not seem like anything strange yet, but let's have a look at this. Let's sketch a little bit of a picture. So, again, pardon my drawings, they're not particularly great. Here's Venus. Here's this probe. It's going to kind of look like a bow tie pasta of some kind. But anywho, when we use the gravitational field strength equation that little g equals big G times m divided by r squared, again, remember that r is that distance between the centers of the two objects. So here's the center of Venus, and then the center of my probe is about here. So that is my distance r. I'm not interested in that distance though. I'm interested in the altitude, which is the distance above the surface of the Venus. So really what I'm interested here is I'm interested in this piece. And the altitude we're going to call h. So the altitude, all it's missing is it's missing that little sliver going from the center of Venus up to the surface of Venus. So really what it's not accounting for is it's not accounting for the radius of Venus, which I'm just going to call RV. That is the biggest trick or trap we can do with these questions, is we can try to tell you about altitude or above the surface. So you have to be really, really, really careful with what you're being told in the question. So first of all, I'm going to need to solve for r. But again, r is the distance between the center of the probe and the center of Venus. So first off, let's solve for r. So I know that the gravitational field strength is going to be G times m divided by r squared. We just did this question, or at least this rearrangement previously. So I'm just going to write the final rearrangement. So the radius is going to be that gm divided by little g, all square rooted. So we have that 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. We have the mass of Venus, that 4.87 times 10 to the 24 kilos. And then we're going to divide that by the gravitational field strength at this point, which is 5.50 newtons per kilogram. And we're going to square root all that. So that's going to give us a radius here. 6.67 times the mass, and then we're going to divide that by g. We're going to get about 7.685 times 10 to the 6 meters. But again, this is only from the surface, or sorry, this is from the center. So distance from center of Venus. Which is not what we're interested in. We are interested from the surface of Venus. So from this, to get the altitude, we have to subtract off Venus's radius. So to get the altitude, subtract Venus's radius. So the altitude is going to be that r value we just found, and we're going to take off the radius of Venus, which we were given in the problem statement. So we got that 7.685 times 10 to the 6 meters that we found, and then the radius of Venus, we have that 6.05 times 10 to the 6 meters. So lastly, what we're going to get is we're going to get about 1.64 times 10 to the 6 meters. So the altitude of this probe, what this is telling us is that the probe, it's about 1.64 times 10 to the 6 meters above Venus's surface, whereas the probe is located this 7.685 times 10 to the 6 meters from the center of Venus. That's the distance between the center and the probe. This is the distance from the surface of Venus to the probe. So you have to watch for those questions where we're dealing with altitude or above the surface. That's the biggest trap that we can lay in these type of questions. So please watch out for those.